Hi everyone. In this given problem statement, we are going to solve maximum depth of a binary tree. We are given a root of a binary tree and to return the maximum depth. So there are few ways of solving this problem. We can solve it through iterative approach or we can solve it through recursion. Here I am going to explain you the recursion process. So here, right, if I have to solve this given problem of this tree 3, 9, 20, 15 and 7. So here, right, once I am the root node, I can go to the left subtree or the right subtree. And now if I go to the left one, does it have any more nodes or any more left or right child? It does not have it, so you're going to return null. Similarly, if I go to 20, I am going to get two more children. So from 15, there is no more left or right child. So all of these values are null, and similarly for 7. So in order for us to do it, the formula would be 1 plus max of left or right, whichever is the higher. So initially, right, let's say if you do not have any more values, right, if our root is null, if their head is null, then we are going to return 0. But in case it's not null, right, then we are assured that at least one value is present, so the value would be 1. Okay, now our left tree, right, what would be the maximum value out here? And similarly in the right side, so in the left side, right, if I come to here, now it is becoming our root node. Okay, and what would be the max of its left and right child? It would be nothing, so it would be 0. So the value out here, right, is 1. Similarly, if I come to 15, the value would be 1, 7 would be 1, but 20, right, because the left, its current value is 1, but this left and right, the max of its left and right, right, it's 1, so the value would become 2. Similarly, here, right, the current value of 3, right, so it is already a node, so it would be 1. And the what will be maximum of 1 and 2, right? It's 2, right? It's 1 plus 2, so value would be the 3, so height would be the 3. Or I can say in this way, 1 plus max of, we are going to form a DFS, let's say we are forming a recursion, right, of our left tree. So it would be root dot left plus DFS of root dot right, and it is going to iterate through the entire list, right, and it is going to divide this entire problem into sub problems, and you're going to get a solution. Now let us jump to the Python solution, and I'm just going to show you the recursive process, but at the same time, right, in the GitHub repository where I'm saving all the code, you can also get the iterative approach. Iterative approach would be pretty similar. Here, right, we can get a stack, and we can, let's say, just to explain you, right, let's say I got the root, right, so I save the root value 3 out here. Then what are the child of 9 and 20, right, and let's say we are going to give it index of 1 initially. Then another, if I pop it out, right, then what are the other two values, which would be 9, because I popped it out, right, it would be 9 and one value, right, it would be 9 2 for example, and 20 uh 2, this is popped out. So from 9, right, does it contain any more children? No, so we are removing it up. And similarly for 20, right, what once I popped it out, right, I'm going to get two more values, 15, it would be 2 plus 1, so 15 3, and 7 3. So, and I can pop it out because it does not have any more children, and 7 3 would be the same. So the maximum value, right, or maximum height that I have achieved is 3. So that would be the output. We can do it with the help of a stack, or we can do it through recursion. So there are multiple ways of approaching the problem. Now let us jump to the Python solution. Now the first thing we are going to check if there is value of root is null, right? So in that case, we are going to return 0. In other cases, right, we are going to return our formula, which is 1 plus the maximum of, and we're going to call this function, so self dot max depth of root dot left, and similarly self dot max depth root dot right. So that would be the formula. Let me run it up. Pretty straightforward, simple solution. As you could see, the public test case is passed. Let me submit the code. And our code got submitted, and we're getting an efficiency of 100%. So our code is pretty efficient. And that's all for this video. See you in the next one.